Let's draw a triangle in OpenGL. First, I will do some CMake stuff for this new tutorial. To skip to the actual coding, go to this timestamp. I will add a tutorials variable, and the code will iterate through each entry. I will add 2 to the tutorials because we are working on it in this video. Now let's start the coding. I will go through the coding quickly, then I will talk about how it all works. To skip to the explanation, go to this timestamp. First, make a new file util.h to house a new function. This function will read a file into a string, and it will be useful later. It will take in the file name, return the contents of said file. Create util.c for the actual source code. First, include the standard headers. Then, include our util header. Now, we will write the body of the function. Make a new file pointer that opens our file. If the file has not opened correctly, we will print an error. The function will return null if this happens. Create a new variable called file size for how big our file is. Then, create the content variable we will eventually return. Move the file's cursor to the end of the file. The position of the cursor is also the file size in bytes. Go back to the beginning to read the content of the file. The content variable will be created on the heap with our file size +1. fret will move the contents of the file into our variable. The last character in our file string will be 0. Close the file, then return its contents. Add shader.h for shader-related functions. GLUint is the same as an unsigned integer. The function will create a shader from 2 files, which are the vertex and fragment shader. Create shader.c for our function body, and include the standard and OpenGL headers in it. Include our shader and util headers, because this function will use our readFile function. We will first create a static function to create a single shader for us, since we need to create 2 shaders. First, we make a new shader. The shader will either be a vertex or fragment shader. Then, the source code is added. The shader code variable contains the GLSL code for the shader. The shader is compiled, but we should still do some error checking. This number will be set in a function to show the shader compilation status. If the result is false, then an error has occurred. We will get the error's length. Then create a variable to print it out. The program will abort because without the shader, there is no triangle. Now we can create our actual function. It will make 2 IDs for our vertex and fragment shader. For each one, we will get the file contents then compile the shader. The full shader will take our first and second shaders, and will be used in the main loop. Both the programs will be attached to it, then the program will be linked. Finally, the shader ID can be returned. Also, I had to fix this silly mistake. Now, we can create a vertex buffer and array to store our triangle in for drawing. The function will take in our vertices, the number of them, and the method in which they should be drawn. First, the vertex array will be generated and bound. Then, the vertex buffer will be generated and bound. We will insert all of our data into the vertex buffer. The data is the x, y, and z positions of the triangle. Then, this attribute will be enabled as attribute 0. The function will return the vertex array. I also had to correct this mistake. Finally, we can write the main file. First, add the headers of our own functions. The points variable will contain all the points of our triangle. Note that the z position for all our points is 0. It is because our triangle is 2-dimensional. We also need to write a simple function which will tell GLFW what to do when the window is resized. This will change the contents of the window to stretch to the screen. I will elaborate on this decision in the explanation. We will set glfw to call this function. Use the shader function here to create the shader. I used these two paths because that is where the shaders are relative to the executable's path. Then, we will create our vertex array. GL static draw means that the points of the triangle never change. In the main loop, the shader program will be used. Then, our vertex array will be drawn. Once the program ends, we have to delete our vertex arrays and shaders. The res directory will contain assets like shaders. Main.vert will be the vertex shader. A vertex shader runs for each vertex, and specifies what will become of its attributes. The GLSL version corresponds with the OpenGL version that is being used. VP is attribute 0, which is our vertex buffer. GL position is where the points will be drawn. I have to fix this silly mistake. The fragment shader runs once every pixel, and determines the color. This vec4 represents white, so our triangle will be white. Let me fix another silly mistake. Run make, then compile our program. Once it is run, a triangle will be shown. Now it is time for the explanation. To read our shader files, we used a function called readFile. We had to get the file size of the given file first. This file size would determine the size of our string which contains the contents of the file. The fret function reads the file's contents into the string. Then, the null terminator is attached to the end of the string, and the file is closed. OpenGL abstracts structures using objects. They can be constructed, bound, and destructed. If an object is bound, its values are allocated, and it can be modified. Some types of OpenGL objects are shaders, programs, buffers, and vertex arrays. Vertex buffer objects can store many attributes about a vertex, such as its position or color. If a VBO is bound, then a call to glBuffer data will assign its data to that VBO. A vertex array object can store multiple VBOs. A VAO and VBO have to be bound to set an attribute index. Attribute indexes help retrieve data from shaders. In GLSL, the in keyword will get the data from a specific attribute index. The first time is it used, it will get data from index 0, the second time, it will get the data from index 1, and so on. I added a glfw callback to glViewPort in main.c to ensure consistent behavior. Without this modification to the code, the program would behave differently on different devices. We are now done with drawing a triangle to our screen. Later on Ancient Straits, we will learn more about shaders and vertex attributes.